All right, well, hello, Discrete Math. This is the second video for this chapter. We're in chapter 3 right now, the mathematics of sharing. In the previous lesson, we had talked about all of the key characteristics to a sharing problem. Today, we're going to talk about our first method for dividing and using a fair division game, which is going to be called the divider-chooser method. So, divider-chooser method is probably the best known of all of the continuous fair division method problems. And again, when we talk about continuous, remember any continuous fair division method was one where you could divide each asset up individually into different sized slices or pieces, as opposed to discrete where you wouldn't be able to divide it up. So be thinking about like cutting a pizza or a cake or dividing up land when we think about continuous. This method can be used anytime the fair division method game involves two players in a continuous set. So again, that's where I was mentioning a cake, a pizza, a plot of land, etc. Most of us have probably used this at one time or another, and it's informally can be described as the you cut, I choose method. It's pretty simple. One player called the divider is going to divide S into two shares, and then the second player called the chooser is going to pick the share that he or she wants, leaving the other share to the divider. So under the rationality and privacy assumptions that we introduced during the previous lesson, this method is going to guarantee that both the divider and the chooser get a fair share. That is, both players are going to get a 50% or more share of the total value of S. Again, remember that's a value in their own opinion. That doesn't necessarily mean that they're split up exactly 50-50. So not knowing the chooser's likes and dislikes, which was the privacy assumption, means that the divider can only guarantee themselves the 50% share by dividing S into two halves of equal value, which is the rationality assumption. The chooser is guaranteed a 50% or better share by choosing the piece that he or she likes best. So as an example, to give you a little bit more concrete understanding of what's going on, we've got Damien and Cleo who are on their first date to the county fair. They buy a ticket jointly for the raffle, and as luck would have it, they actually win a half chocolate, half strawberry cheesecake. Damien likes both chocolate and strawberry equally well. So in his eyes, the chocolate and strawberry halves are equal in value. On the other hand, Cleo hates chocolate. She's allergic to it and she gets sick if she eats any. So in her eyes, the value of the cake is 0% for the chocolate half and 100% for the strawberry part. Once again, to ensure a fair division, we'll assume that neither of them knows anything about the other's likes and dislikes. So we're going to assume that Damien doesn't know that Cleo's allergic and vice versa. Okay, so Damien volunteers to go first and be the divider. He cuts the cake into a perfectly rational division based on his value system. Each piece is half the cake, and to him, worth one half the total value of the cake. It's now going to be Cleo's turn to choose, and her choice should be pretty obvious that she's going to pick whichever piece has the larger strawberry part. The final outcome of this division is that Damien gets a piece that in his own eyes is worth exactly half the cake, and Cleo ends up with actually a better deal, a piece that in her own eyes is worth about 2/3 of the cake. This is nonetheless a fair division of the cake. Both players get pieces worth 50% or more. To go back a little bit more on that, you see the way the cake is divided. Even if he had tried to divide it more straight 50-50, so let's say he cut it down the middle in half, Cleo's still going to pick either half at this point, and still going to get 50% of the cake that she planned to eat in the first place, be it this half or be it this half. And no matter what she chooses, Damien's going to get half of what he wants, because no matter which half he gets, he's going to be happy since he values both sides equally. So it doesn't matter how the cake was split, each one was going to end up with a perfectly fair slice of the pie, so to speak. Okay, now, it is better to be the chooser. And this example illustrates why, given a choice, it's always better to be a chooser than the divider. The divider is guaranteed a share worth exactly 50% of the total value. But with just a little luck, the chooser can end up with a share worth more than 50% like we just saw. Since the fair division method should treat all players equally, both players should have an equal chance of being the chooser. So this is done by means of a coin toss or some other method where the winner of the coin toss gets the privilege of making the choice. So you do have kind of an initial 50-50 shot of being the divider or chooser, obviously the chooser being the one you'd prefer to be. All right, like I said, pretty short method, pretty easy, I think, to understand. If y'all have any questions, let me know. We're going to look at another method in 3.3.